Hello, students. Welcome to Unit 7, Lesson 4. This is an introduction to probability with area. So we have a warm-up here, so I'll do it with you today. You roll a six-sided number cube. Find the probability of rolling each of the following. So a six-sided number cube is a die, like a set of dice. So what's the probability of rolling a 4? Well, there's a 1 in 6 opportunity to roll a 4. For the next one, an odd number. Well, let's think about the odd numbers that we have. We have 1, 3, and 5. 2, 4, and 6 are even. So we have a 3 and 6 opportunity to roll a odd number, and we will simplify any probability to the simplest fraction, which is 1/2. A 2 or a 5, well, those are 2 out of 6 opportunities to roll, therefore it's a 1/3 probability. A prime number, so we got to think about our prime numbers. 1 is a prime number, 2 is a prime number, 3 is a prime number, and 5 is a prime number. 1 is a prime number. I'm sorry, 1 is not a prime number. I apologize. Just 2, because 1 is the factor is 1 in itself. So we ignore 1, 2, 3, and 5. 4 and 6 are composite because they're divisible by 2. So this is I apologize for that. This is a 3 out of 6 opportunity, making it a 1/2 probability, theoretical probability. You roll a 14-sided number cube. Find the probability of rolling each of the following. So a 7, so this is a 1 in 14 opportunity. A 9, 10, or 11 is a 3 in 14 opportunity. A composite number, so the prime number, so we'll say 1, 2 is not, 3 is not, 4 is a composite number. Okay. 5 is not a composite number. 6 is a composite number. So 1, 4, 6. 7, 8 is a composite number. 9 is a composite number. Factors 3 and 3. We have 10. 11 is not, but 12 is. So it looks like we have 1, 2, 3, 4, 5, 6, 7 of them out of 14, making the probability 1/2. And I'm just going to bring this down so you can see it. And this last one, an even number. So 7 of the 14 are evens. We have 2, 4, 6, 8, 10, and 12. Therefore, it's 7 out of 14, which is also 1/2. All right. Actually, you know what? 1 is not a prime or a composite number. I'm sorry. I don't know why I keep getting stuck up on that. So we're actually going to call that 6 out of 14, and that is 3/7. Yeah, 1 is always strange. I always get that one mixed up. It's not prime or composite, so just 4, 6, 8, 9, 10, and 12. All right, so our lesson today is about geometric probability. So we are going to determine the probability of events based on our favorable outcomes divided by our possible outcomes. So for instance, if I have a square with another square inside of it, whoops, just going to shrink this one. And let's say I had this shaded, whoops, and it was a quarter of this, it would be, what's the probability of something landing in this shaded region? That's a 1 in 4 opportunity. And let's say that this square was a 2 by 2, and this square in here is a 1 by 1. So that's a 1 by 1, while the total area is a 2 by 2, so it's a 1 by 1 is 1, 2 times 2 is 4, so it's a 1 in 4 opportunity. Looks like about a quarter of it. So it's the probability of the event occurring. Geometric probability is also just specifically about a length or an area or a volume being favorable over the volume or area or length of an entire group of something. Okay, so this was this was more of a geometric example right here. Okay, so what's the probability of a fly landing between 3 and 7 on our number line, on our ruler? So there are 12 inches. So let's see, there's 1 total inch, 2 total inches, 3, 4, 5, all the way up to 12. So there's a possibility of getting a total of 12 inches. Between 3 and 7, let's look at 3, let's look at 7, let's count how many. We have 1, 2, 3, 4 inches. So we have the probability of a fly landing on 4 out of 12 of these inches, making this a 1/3 probability between landing on between 3 and 7. What you can do is you can count, don't count 3 and don't count 7, count from 3 to 7. Because if you count 1, 2, 3, 4, 5, you're actually gonna get the incorrect amount. It's a total of 1, 2, 3, 4 inches. And you can figure this out as well by doing 7 minus 3 to get 4. Okay, the next one, a point on AB is selected at random. What's the probability that the point is on CD? Well, it looks like from A to B is 1, 2, 3, 4, all the way to 10. So it looks like we have a 1/10 opportunity for that to occur. And from C to D, it looks like it's 1, 2, 3, 4. Again, I could do 8 minus 4, which is 4. So it's a 4 in 10 opportunity, making it a reduced fraction of 2/5. So it's a 2/5 opportunity for that to occur. All right, next one. Elena's bus runs every 25 minutes. Okay, so let me draw the bus schedule. So let's say the bus runs every 25 minutes. I'm just going to put this on a number line. So it's at time 0. So it stops at their bus stop. And here's another 20. So this is 25 minutes later. It stops 25, and then it's going to stop again. Just going to bring that over a little bit, trying to make it equidistant here. So it's 50 minutes, 75 minutes, and so on. Stops. Okay, then it says, what is the probability that she will have to wait at least 10 minutes for the bus? Okay, well, if it stops at minute 25 and she gets there at minute 10, minute 15, then what's the probability that she has to wait at least 10 minutes? So this is 10 total minutes. So what I'm looking for is anything shaded here really is the ability of of her having to wait. And this keeps repeating, so it doesn't matter how many times we do this, but we can just repeat this process over and over, and she's going to, let me just move this stuff over a little bit to make it look a little bit better here. You see that no matter how many times, we only need to look at one cycle of this occurring, right? So it's 25 minutes, 50 minutes, 75, 100. It just keeps doing that over and over. But this amount of time, from minute 0, from the time the bus leaves, there's all this time in between that she would wait at least 10 minutes. If she's here at minute 1, she has to wait 24 minutes. If she's at minute 2, she has to wait 23 minutes, and so on. Up until minute 15, she's waiting for 25. So let's not get too particular here about this microseconds in between it leaving and it being 15. Let's just say that the total is 15 minutes in. So from 0 to 15, she's waiting. And there's a total of 25 minutes of one stop. So it looks like 5, 10, 15, 20, 25, 3/5 of the time. The probability is 3/5 of the time she'll be waiting at least 10 minutes. Okay, we could even round this if we want to say 60%. It's 0.6 as a decimal, which is 60%. So 60% of the time, the probability she waits at least 10 minutes that Elena waits at least 10 minutes is 60%. All right. And so if that's the case, that she waits no more than 10 minutes, that's actually the reverse. So I'm literally just gonna copy this over. I'm gonna do the opposite. I'm actually gonna shade this part. So it's a repeat process. What is the probability that Elena will have to wait no more than 10 minutes? That is, so it's 25. What we can do for this one, we can do 25 minus 15 over 25. And that's 10 over 25, which is 2/5 or 0.4 or 40%. So the probability, notice it adds up to 100. Probability that Elena waits at least, no, at most 10 minutes is 40%. So we could say Elena waits, Elena, most likely will wait, will be waiting at the bus stop, either more or less than 10 minutes, one of the two. All right, next one, finding probability using area. So here we have a dartboard. We have a blue dot on the inside. This is our center. We have a yellow dot that, circulates that. And then we have a red dot. Well, I keep saying dot, but we have a ring, I should say ring. And we also have this dartboard. So we have a lot of probabilities happening here. What I'd like to do before I even start answering any of the questions is just find out the area of this blue one, of the yellow one, of the red one, and then of the whole thing, and then I can start to answer questions. And the questions are, what's the odds of it landing in the 1-inch circle, the 2-inch circle, the 3-inch circle? So what I'm going to first do is I'm going to find the area of the square. The area of the square is 12, so the area of a square is base times height, which is going to be 12 inches by 12 inches, which is 144 inches squared. So I now have 144 inches squared. Now, obviously, there's something here. We got to take this away later on, but let's just find the area of each one as if it was full. So the next one I'll do is this, this blue one, the center blue one, and so hold on, let me change this to a different color so it kind of matches. That's a good color. Kind of matches the square there. So now I'm going to find the area of the blue circle, assuming it's full. So the area of the blue circle, is going to be pi r squared, because that's the area of a circle, pi r squared. So I'm going to do pi times, it says it has a radius of, the radii is 1. So it's going to be pi times 1 inch squared, which is pi times 1 inch squared, which is 1 pi inches squared. Okay, so now the area of the yellow one is going to be pi r squared, which is pi times 2 inches squared, which is pi times 4 inches squared, which is 4 pi inches squared. I just rearranged it. So that's good. But then don't forget, I have to also take away this blue area that I found earlier. Okay, so I'm going to actually take away minus a pi inches squared. And I end up getting 3 pi inches squared. So actually, let me say the yellow circle. Let me call that yellow ring. Let me call it yellow ring. Because it's not a circle, it's a ring. Okay, so that's my yellow ring is 3 pi. The whole thing would be 4 if this blue part wasn't filled in. So it's really all 4, take away that 1 pi. So we get 3 pi inches. Okay, so the area of the red ring, let's find a color that matches that red. What do we think about that color? That's maybe a little bit too dark. It's not perfect. Let's say the area of the yellow ring is going to be pi r squared. So we get pi times 3 inches squared equals pi times 9 inches squared. We're squaring the 3, squaring the inches. We have 9 pi inches squared. And what we have to do now is we have to take the yellow ring and the blue circle away. So I can use 4 pi because that was the area of the yellow circle, assuming the blue wasn't filled in, and call it a day. Or I can do the 3 pi and the 1 pi. So let's just, let's make it more complicated than we have to. Why not? Let's just take away the 3 pi inches squared, and then we'll take away the 1 pi inches squared. Again, I could have just taken away 4 pi because that's this whole thing, but I did it separately just to show you like what's going on. I'm taking both away. So 9 minus 3 minus 1 is 5. Right, 9, 8, 7, 6, 5. So 5 pi inches squared. All right. And I kind of made a mistake earlier. I found the area of the square, but what I need to do really, and I'm going to need a little bit more room here to do it. Let me move all of this up. Save some room here. Okay, that's good. What I need to do is take my square and take away the red ring. Again, I can just take away 9 pi if I want from this. I can take away 9 pi. But wait, hold on. Actually, I don't need to find the probability of hitting anything but the blue, the yellow, and the red regions. Okay, if I want to know what's shaded in gray, I would just take away this ring, and this circle. I would take away 9 pi total, so 5, 3, and 1. But I don't need that. I just need the area. Instead of me calling it of the square, because that would involve me taking away, part of it, I'm going to say area total. I'm just going to change this to total. So the area total is 144. So it says, find the probability of hitting each of the blue, the yellow, and the red regions. The radii is concentric circles 1, 2, and 3 inches respectively. Okay, so what I need to do is the probability of blue circle is going to be 1 pi divided by 144. So it's 1 pi inches squared over 144 inches squared, which will get, we're going to do 1 pi, which you don't really need the 1 because 1 pi is the same as pi, divided by 144. So it's the probability of this happening. And because it's a real world problem, I'm going to actually give like a real world solution here. I'm going to round it 0.0218, which is approximately, multiply this by 100, and I'll get a percentage, 2.18%. That's the probability of it hitting the blue circle. And now the probability of it hitting the yellow. What's the probability of it hitting the yellow ring? Probability of hitting the yellow ring, we said we got it down to 3 because we had to take that 1 away. So 3 pi inches squared over 144 inches squared, which is approximately, I'm just going to change this 1 to a 3. I already have the work done for me. I'll take the 100 away first. That's 0.0654. Sorry, I am making my lesson in the guidance office, and there's a doorbell. All right, so we multiply this by 100, and we get about 6.54%. And the last one now is that red ring. And so the probability of the red ring is going to be, what, we got 5 pi, because we got 9 pi minus 3 minus 1. So again, these are my areas, and these are my possible areas over my total area. So that's the, we're just following that geometric probability, which is the length or the area of the favorable segment over the area of the entire, the total area. So I'm going to delete this, change that to a 5. I already have it done. So this is 0.109. I'll round that to a 1. And so this is about, so times 100, change it to a percent, I get 10.91%. And that's it. Those are my final answers. And if I want to know what's the area of hitting all 3 of them, I can just work with 9 pi to find that, because it's 5 pi plus 3 pi plus 1 pi, which is 9 pi. Okay. So, if you change the blue circle as indicated, how does the probability of hitting the blue circle change? So what happens if I double the radius, and what happens if I triple the radius? Well, if I double the radius, I get 4 pi. So doubling the radius gets me 4 pi. Double 1 equals 2. So I get 4 pi. Whoa, so I'll do that. Area of the blue circle equals pi r squared, which gets me pi times 2 inches squared, which gets me 4 pi. So doubling the radius gives me 4 times the amount of area. Right, compared to 1 pi, I now have 4 pi. And then what I can say about triple 1, so if I triple, I'm not paying attention, triple 1, I get 3, so I get instead of 2, I get 3 inches squared. That gets me 9 pi. So 1 times 9 is 9. So it's 9 times the amount of area. So what I'm doing is, because I'm squaring it, it wants me to make the connection that 3 squared is 9. So it's going to not triple the amount of area, but triple the amount of area twice. Well, triple the amount of area and it's squared. So we have to we know it's square units. So 9 and 4 are squared units here. And actually what we would do is 4 pi would be these two combined. So it would be about 8.6, 8.7%. And if we tripled it, we would get 9 pi, which is the red circle, which is all three of these. It's the blue circle, the yellow ring, and the red ring. So we get 10, 16, 17, 18, 19, almost 20%.